Assalamualaikum warahmatullahi wabarakatuh, and greetings for my lecturers, which is Dr. Zuraidawani binti Cik Daud. My name is Muhammad Dami Zamri. My matrix number is 23131104 and I am course Engineering Technology and Management. So this presentation about assignment 3, which is for presentation material selection, aerospace application based on reservoir and allowance analysis. So for the overview, which is subtopic introduction, problem, background program, PW and AW result, summary, consequences of raw material choice, sustainability, resource efficiency, and conclusion. Right. For this introduction, I will express my opinion on which material should be selected for aerospace application based on pressure worth and annual worth analysis. So this presentation will cover why this material, which is material X and Y, is better choice, the consequences of choosing the raw material, and how limited aerospace resources can be used sustainability and sustainable and efficiency. For the background, in aerospace engineering, material selection is extremely critical part because it affects cost, safety, performance, and sustainability. So in this assignment, two materials were evaluated, which is material X and material Y, and also both material have different initial costs, annual maintenance costs, and long-term economic impact. So this is the PA and PW and AW result, which we can go through after this. So first, the table of data for material X and Y, as mentioned before, have a initial cost, maintenance cost, salvage value cost, and life for material X and Y. Next, this is the flowchart diagram material X and material Y. The left side is material X flowchart, and the right side is flowchart material Y. And both of flowchart is using the interest rate or MARR, same value, which is 12% per year. So this is the calculation for get the value of preserve worth meter X and preserve worth meter Y. And the left side is reference formula that got from the lecture note. So the value of preserve worth material X is negative 60,308.4, and the value preserve worth for meter Y got 31,114.4. Next, for the annual worth meter X, we got also negative, which is negative 4,519.4, and for the annual worth meter Y, we got 5,848.70. Before that, I forgot. Based on the PW and AW result, I strongly recommend for choosing material X because first, material X has a lower pressure worth compared to the material Y, and this means that when all costs over the service life are convert to this value, material X requires less total investment. Second, material X also showed lower annual worth, and this indicate that the equivalent yearly cost of material X is lower and make it more economical and in or for long time operation. Although material Y has advantage such as possible lower maintenance or higher performance, burden is higher when evaluated using engineering economic methods. Therefore, from an engineering economic perspective, material X is better to choice. Alright. Next, we go to the consequences of raw material choice. So, choosing the raw material in aerospace can lead to the serious consequences. Example, cost impact and safety impact. So, first, the cost impact. If material Y is selected despite its higher PW and AW, so the point is operational costs will increase. Second, maintenance budget may exceed projection. And third, the project may face financial inefficiency over its lifespan. So, next for the safety impact, in aerospace, financial stress can indirectly affect for safety. Example, reduce maintenance frequency, delay inspection, or compromise component replacement. This could increase the risk of component failure, which is unacceptable in aerospace system where human life are involved. Hence, an economically inefficient material choice can eventually compromise both cost, control, and safety. So, second last for the presentation is about sustainability and resource efficiency. Aerospace resources are limited and expensive, so sustainability must be considered by choosing material X because we can reduce unnecessary financial waste, allocate safe resource to R&D, research and development, safety system, and efficiency improvement. And lastly, extend the usable lives of component through better cost management. So, lower annual costs also mean reduced overproduction, better life cycle planning, and more responsible use of material and energy. Lastly, for conclusion, the final decision is based on the preserve worth and annual worth analysis. Material X is the most suitable choice because it offers lower long-term costs, better economic efficiency, reduced financial risk, and more sustainable use of aerospace resource. This is because a correct material choice is not only about performance, but also about long-term value, safety, and sustainability. Thank you.